Okay, so welcome back to this next video in which we are discussing clathrin-mediated endocytosis, where we're specifically looking at the role of Dynamin 1 and endophilin. Okay, so we've discussed how Dynamin 1, when it is dephosphorylated by the calcineurin enzyme up here, it becomes activated, and then what it starts to do is it starts to oligomerize on the neck of the clathrin-coated vesicle bud. This forms a sort of spiraling polymer around the neck of the clathrin-coated vesicle bud. And the oligomerization of the Dynamin 1 activates its GTPase activity. So it starts breaking down GTP into GDP and inorganic phosphate, and it uses the energy released from that hydrolysis of GTP to tighten the spiral and reduce the diameter of the lumen of this tube connecting the vesicle with the extracellular space. Okay, and when it does that, it stretches the neck in length, basically. So this is the pinching off process. So we now want to look at the protein endophilin, okay, and what its role is in this process of pinching off. So endophilin. So endophilin is a protein which dimerizes. So basically, it forms this sort of banana shape when it dimerizes. So two endophilin proteins come together like this, and they form this sort of banana shape like this. So the protein has an intrinsic curvature. So here is one endophilin protein, and here is the other one. So you've got this dimer of these endophilin proteins. And basically, when you look at the charge distribution on these endophilin proteins, what you find is that the outer aspect, the aspect here, the, how shall I say this, the portion that's inside on the curvature, basically. So this portion, as you can see, is the sort of outer portion, and this is the inner portion. It's the concave portion. Okay, that's the proper word for it. The concave side here, whereas this is the convex side. Okay, so the concave side here, there is a lot of positive charge on this concave side here. So what we think endophilin does is that it also wraps around the neck of the clathrin-coated vesicle bud and forms rings of endophilin, which also helps in the pinching off of this clathrin-coated vesicle bud. Okay, so what will happen is basically you'll take multiple of these together. So this is one dimer. What you'll do is you'll take multiple dimers. So here's one endophilin dimer here, forming this sort of banana structure. What you'll do is take another one of these. So let's put this here. Okay, here's another endophilin dimer. And then you could join it with more. Now, I've shown 3 here completing the ring. It will be far more than that in reality. But to save time, I've drawn 3 here completing the ring, 3 endophilin dimers, so overall 6 endophilin proteins. So they form these oligomers where they wrap around the neck of this clathrin-coated vesicle bud here. Okay, so they assist the Dynamin 1 protein. And consistent with this finding, what we find is that if you look at these proteins, these endophilin dimers, and you look at, if you were to assemble a ring of them, what the diameter of that ring would be. Okay, so I'll say this again. You look at the structure of these endophilin dimers, you look at how much they curve, and then you do a calculation to work out how big the ring that you could construct out of these endophilin dimers will be, i.e. how big the diameter is. Then basically you find that this will be around 200 nanometers, okay? And this is exactly the right sort of diameter for this neck of this clathrin-coated vesicle. In addition, what you find is that if you put the endophilin dimers in with circular liposomes, so let's say here we have a circular liposome, then basically what the endophilin dimers do to the circular liposome is they cause it to take on a tubular structure. So basically you will start off with your circular liposome, and if you put this circular liposome in the presence of the endophilin proteins, it will convert it into something like this. And we think what is happening basically is that the endophilin is polymerizing and forming these rings around the liposome and creating these tubular structures like this. So it will convert a circular liposome into a tubular structure. So this is a circular liposome, and it will convert it into the tubular structure. Okay, and basically when you look at the diameter of these tubes, it's 200 nanometers, so it's perfectly consistent with the structure of the protein. Okay, so to summarize then, what we think the role of Dynamin 1 and endophilin is. So, you get this clathrin-coated vesicle bud, okay? You need to pinch off the connection between the lumen of the clathrin-coated vesicle pit here and the extracellular fluid, okay? So what you do is, one, you assemble endophilin rings around there, which will help to sort of reduce the diameter of this tube. Okay. In addition, and probably more important than the endophilin, certainly more important, you activate the Dynamin 1 protein when the calcium goes up in the cytoplasm of the axon terminal, and the Dynamin 1 protein oligomerizes around the neck and basically forms these spirals that spiral around the neck. And then the oligomerization activates the GTPase activity of Dynamin 1, okay? And when the Dynamin 1 starts hydrolyzing GTP to GDP and inorganic phosphate, then the energy released from that hydrolysis is going to be used to tighten the Dynamin 1 spiral around this neck, thinning the lumen hugely, the lumen of the connecting stalk between the clathrin-coated vesicle bud and the extracellular space, and lengthening it at the same time. And what's going to happen basically is that that's going to pop this vesicle off basically, and then you will have a clathrin-coated vesicle. Okay, right, so that's the process of pinching off then. In the next video what we'll look at is some experimental correlates of this